Good morning, good afternoon, sorry. Good afternoon, everyone. Good afternoon, sir.
Good afternoon.
So, Dr. Mylswamy Annadurai is a renowned Indian scientist, famously known as the Moon Man of India. He has worked in various capacities at ISRO for 36 years and was the project director of Chandrayaan-1, India's first mission to the moon. He also served as the program director of the successful Mars Orbiter mission, or Mangalyaan. He has contributed significantly to enhancing India's capability to produce state-of-the-art satellites and satellite-related technology development. In 2016, he was conferred with Padma Shri, the fourth highest civilian award in India. He continues to inspire students and youth with his motivational speeches and handful of scientific books. And now he is here with us today to encourage us with his motivational address. And now I request Dr. Mylswamy Annadurai to begin his special address. Sir, you can continue.
Yeah, thank you. Without much of a delay, what I will do is, anyhow, I'll come back for the interaction after my presentation. So straight away, I will go my presentation using a PPT. Is it okay? I think you can allow me for the share screen.
Yeah, you can share.
Yeah, please. Yeah. Hope you are able to see my view graph.
Yeah, we are able to see the.
Yeah, fine. Yeah, this basically this first view graph will able to capture space and the sustainability. When we are talking about the Space Week, World Space Week of this year, space and sustainability. You look at here the early 60s. Okay, I think 59, 58 time frame. The world around was very small number of satellites, one or two like that. After Sputnik on final type of thing came. In 70s, slowly got crowded. 80s again crowded. Now 90s, 2000, 2010 onwards, you look at here, the globe is getting crowded with so many number of satellites. Because initially it was experimental and then some sort of a scientific competition, but now it's a more and more into the communication, remote sensing, navigation, then for the defense, along with that the science, like that so many activities started coming. Number of activities started coming using the space, what can be done. The number of countries who can be participate of this also is keep increasing. And even within the country also, I think now a good number of private industries also coming. So that is making the number of the satellites going around the Earth is exploding beyond 2010. That actually this is still going up and up and up. But while that is happening, our dependence, for example, you look particularly when looking about India, a developing country like India, to leapfrog, because the first two industrial revolution, India was not part of it. But India, yet very fast, it's moving forward, and India shortly will become the number one in the population. So that means to humanity to touch science and technology has to come back, even though first two industrial revolutions we could not really make it because of educational institutions, science and technology forums, so many thing point of view. I think today we need the technologies to be connected. So that way, the upcoming the space era, India is trying to corner its own interest for their people. So Indian space program also keep coming up, and definitely needs coming to in a much bigger way, because India is a country of unity and diversity. Your various things. India is a traditional country, but it has a modernity also coming. Its unity and diversity is there. Caste and class is there. Individualism and collectivism, spiritual and materialistic, mutual respect and tolerance. I think so many things. So this is more than the country. It's more of a subcontinent, having a variety of compositions, issues, and opportunities. Yes, you think about. So now the point of thing is satellites possibly will able to connect these things. Either, for example, whole India weather forecast can be given better way. The whole of India, we can give the navigation can be done better way. India having the borders with enemies that can be protected by our satellites. India is a country where having all the three sides connect with oceans and sea that gives tidal waves, cyclones, tsunamis. So to protect the people, we need the satellites technology, which will enable us to do something better. So like that, and India is a country of so much of agricultural land and farmers. For them to tell various inputs are given, the satellites can be used. So like that, satellites will be able to connect the people in a much better way, especially in the Indian context. That's the way our dependency on the satellites are going up and up and up and up. When that's happening, basically look at here. We cannot just keeping the satellite just around India alone. It's going around the globe. But notwithstanding that, now you look at here, the cell phone, if you take, you need at least 1 or 2 cell phone towers you're nearby. Then only you can cell tower possible. But it is not possible to have a cell phone across the globe. So that many places that connectivity is not connected. So even during the pandemic, some of the even online schooling came, education there. There are the places where the people that could not reach because the coverage is not there. But whereas putting the satellite, this just giving concept. You look at here, any point of time, any part of the world, it's possible to connect minimum of 6 to 7 satellites visible with some 24 satellites going in a particular orbit, in a particular way. So now you increase the number of the satellites this way, and that connectivity will much improve. That means anywhere to anywhere in the world, connectivity is possible. Once you connected, that connection will help for very many things. For example, you and me, I am sitting in Bangalore. You are sitting your classroom, or 2 different classrooms. You are watching me. Like that, wherever you are there, wherever I am going to sit, you can connect it, and that can be for various purposes. For education, even surgery, super specialty hospitals from to a primary health center can be connected. And once you are able to connect it neatly, this can be done. So like that, very many things are possible in principle. So to make that to happen, as I told, slowly it is very few satellites trying to do in principle. But now you have to connect it in so many places. So that way, the number of satellites, like your cell phone towers, number of the satellites sitting in the space, increasing exponentially. Okay, and that exponential, to make it, even given time, not a single satellite being launched, it is being tens or hundreds of satellites being launched one shot. For example, this particular view graph, I don't know how many of you have seen. Many of my presentations are given. Probably last time when I'm meeting also would have shown you. So this is one of the things. Of course, we also launched like this. Now you look at here, each one is one satellite. This one satellite, this another satellite, the another satellite, another satellite. These are all stacked together. Okay, stacked together 2 rows here and here. And that is kept on the top of the launch vehicle. For example, here, this being a launch vehicle, and the nose of the launch vehicle, all these satellites stacked together, okay, kept there. And that launch vehicle is launched to the orbit. And when it's reaching the orbit, this heat shield will open. Then one by one, the satellites will be ejected into the orbit. So that what I told now, to make number of satellite constellation, to go around the world to connect the people, like our Digital India, when we tell about, for various aspects, we have to connect the people, okay? And that point of view, this hardwares will be placed in the orbit. So then, after the satellite launch vehicle has gone into the orbit, you can look at that, how it is being injected out, okay, one by one. You look at here, one by one, how the satellites will move. Here, the end mass, it's pushed out. Okay, that is one particular stack from the launch vehicle. Then afterwards, one by one, the satellites will be moved into the orbit, and after that, those things will getting spaced in a way such that you will be able to see like this. Okay, the satellites will keep moving around. So finally, the satellites in the orbit will be like this, but will be launched in bulk way, in a bulk way. All put together, so many satellites will keep going around. As I told now, how over the years in 60s to now, how the number of satellites keep on increasing. Now, once put so many, for example, the particular one constellation will consist of around 42,000 satellites. Okay, like our Airtel is there, like Jio is there. They have their own cell towers, na? Like that, their own satellites will come like this. Then they look like as if a big mess around the globe you are able to make it. That means anywhere to anywhere in the world you can connect it through the satellites and to the ground. Okay, that way it comes. That means anywhere to anywhere connectivity is possible. The connectivity will enable very many activities to be done by the man, irrespective of wherever he is. Okay, he did not go fly to US to do something. Sitting here itself, we can make it that to happen here. So very many other activities will happen once connectivity comes. Once the roads are made, using the road you can travel from your place to Chennai or Madurai or Mumbai for various purposes. It can be educational tour, it can be medical, it can be just a pleasure trip, or for any other interview. It can be anything, correct? No? So similarly, once you connectivity through this happen, through that many has been done that. But now in the process, what happened across the globe? Now so many satellites started moving. Okay, this is not only active satellites, and the satellites after launching maybe 5 years, 6 years, 10 years, like that, satellites may lose its life because the fuel has gone, the battery has drained. Like your cell phone, after some years, it will not able to make use now. Like that, satellite also it can happen. So when that happens, that also will keep going around. So like that, across the globe, now the number of satellites going around is increasing. But our dependency on the satellites in the ground also increasing. Okay, for various aspects. But we have to use our satellites. If satellite is not working, various functionality. For example, if you go to ATM, some satellites, if don't work, from ATM you cannot draw the money. Today, your bank account can be anywhere, but you go anywhere in the world, you can draw the money. That feature available thanks to this connectivity. But this connectivity fails, you cannot do that. Okay, like that, various things. The dependency on the satellites are there, but satellites are getting crowded so heavily. So, like your car previously from your house to school to come, if it's a village, less traffic can come. But more and more traffic comes. Sometimes it will get delayed. Sometimes it can. Some accidents also can happen. Correct now. So now slowly that possibilities keep happening as the space is concerned. That means now, for example, today look at we told that so many pictorially this many satellites have come. Just to give a small clip of how many active satellites. Not active is still much more, but still even active satellites in a low Earth orbit. There are various orbits are there. Okay, somewhere around 400 to 800 kilometer orbit, low Earth we will tell. So that orbit more than 3,300 satellites. I think it's keep growing. And similarly, medium height around 139 satellites. Geostationary 36,000 kilometer has around 560 satellites. Highly elliptical orbit around 57 satellites. These are all the active satellites. This number itself is high, but this number is but this number will keep increasing. I told now the 3,000 we can in future it can touch to someone 40-50,000. Possibility is going because people are launching the satellites as I told here. In a single launch itself, so many satellites being launched. So the number is exponentially keep increasing. Then when that happens, when such a thing happens, as I told, what has happened in 2010, how many satellites? To 2020, now it's looking at here, the number of satellites have gone up and up and up. So that means number of, now, not only this active satellite, when launching, for example, I have given one curve here. Look at here, whatever previously I shown you pictorially, this tells how many number of satellites it's coming. Recent past, it's keep going up also. Okay, recent past it's going up. It's recently now it's crossed even 4,000 because single launch 56 satellite can be launched. People are week after week they're launching. It's keep exponentially keep increasing. So this will give a challenge. 3 challenges. What is happening is like in the Earth. Earth also whenever we want we are taken a water. Wherever it is there, many things trees we cut it when used it. Many things are keep going. But so many people are populated. So the Earth, that sustainability issues started coming in Earth. Okay, that means this generation all along up to the generation people are using. The previous generation, whatever used, nothing has happened for the earth resources for the next generation. But this particular generation where you and me are living together, there is a big question mark has come. This generation, after the generation, in the future generation, whether the world will be the same fertile, the water resources, whether it will be the same, air, whether it will be the same, okay, food item, whatever are keeping, whether it will be the same. So whether people will be able to sustain their thing in the future also. While we should use the earth. Without that, food, water, air not possible. But when using it, you over exploitation if you do, there is a possibility for the future generation that may not happen. So sustainability questions have come for various forms for the earth living. Now slowly in the space also, though many ways we are using the space. Now so much you keep crowding, there issues are coming. That means one satellite goes and hits something else. What will happen? Okay, then it will do a cascading effect can go. So many things are there. One hits and creates a problem that many things can keep hitting. So it creates a really big challenge. And these numbers, whatever I told, is only active satellites. But for various reasons, small pieces. After the satellite PSLV goes, you put the satellite, but it's on fourth stage sitting there, and it's a fourth stage. After some time, there is like our, not only ours, other people's also. The fuel, if it gets expanding, there is a possibility the whole thing will get explode. When explode, it will give so many pieces. And not only that, there are many countries, United States, Russia, China, even India also twice tested. Many times, whatever the satellite sitting there for military purpose, okay, people want to attack, like Air Force, aeroplane to aeroplane fight will be there, ship to ship fight will be there in the Navy, man to man fight will be there in the Army. Now, the space also taken as another fourth command of defense and security. So there also people are trying to test, like an aeroplane you are shooting, is it possible for the enemy satellite to shoot? For that, to get ready, people testing their own satellite, which has lost its life. So, but it generates a lot of debris. So that like that, United States 30 times tested, Russia 32 times tested, one recent test also they did. China 10 times they tested. Of course, we also have done that way. So those things also create a lot of debris. So now all put together, look at here, anything above the 10 centimeter like a particle, 34,000 sitting there in the orbit. And between 1 to 10 centimeter, it will be 900K. That means 9 lakh particles are there. Less than one, that is between 1 millimeter to 1 centimeter, it may like small, but those things are traveling much faster rate. Okay, nearly 30,000 kilometers per hour. That speed it's traveling. When it is traveling, it hits an active satellite like a bullet. Okay, so the particle is maybe 1 mm or 2 mm, less than 1 centimeter. That number is 128 million sitting there in the orbit. Okay, by any chance, and they are moving very fast also. So that means so many bullets are keep on going, crisscrossing, and your satellite is going. By any chance it hits, it will get into problem. Okay, so this is the situation we are having right away. But beyond that, as I told, now very fast we are launching the satellites. Every launch, so many satellites we are launching. For example, now the very private industries also started coming. SpaceX, the Elon Musk Starlink, they are planning somewhere in more than 41,000 satellites to be launched. Already they launched more than 500 the last 2-3 years itself, and they want to accelerate it and they want to make it that their own number of satellites itself, their own number of active satellites itself, they want to make it 41,500 type of thing. But that satellites, once life is over, they want to replace with other satellites. That means that many number of satellites will keep on increasing. Similarly, China is planning around 13,000 satellites, and our own Airtel, OneWeb, they are planning around 64,000 satellites. Sorry, 6,400 satellites. Like that, so many that's their satellites, and many people are few thousands are going to launch. That means in the near future, number of satellites, number of particles going around the space is going to be a real issue. Real crowding going to happen. Along with that, the space security is also keep coming. That is once in a while something they tested, that debris also keep coming. So this gives a big question mark about the space sustainability. That's why that we are discussing about that. So this is whatever the summary, whatever I told is, orbit is getting crowded beyond what already it's have. I already told a few million less than 1 centimeter particles are there, and a few thousands 10 centimeters are there, and similarly few hundreds are for 3 or 4,000 sitting there for the active satellites. But this is going to be immediate near future. In the coming years, each one of them, people are going to launch this many satellites. So this is going to really orbit is getting crowded. That means orbit crowding with the satellite and space junk can cause both physical congestion, like our traffic issue, what is happening in the roads. I think how many of you are seeing in Mumbai or Chennai, Coimbatore cities, road traffic, some places the traffic will not move for 10 minutes, 15 minutes like that. So many people will get crowded, and until somebody gets this, cannot go. And there is some places, some accidents also can happen because of this. So that is that sort of a thing. But now slowly this is happening in the orbit. But here it's not only physical damage. Each one of the satellite emits the electromagnetic signal. Then only we can using them, you can communicate. Connectivity, I told you, it's only flying. But to connect for various reasons, it's using electromagnetic waves. So now this all the thousands of satellites use this electromagnetic wave. There is another issue of beyond physical, it can interfere with each other. Okay, that also can create another issue. Okay, this both issues also there. But now that means like COVID, like a plague, like that human is getting some issue. Similarly, space is also getting an issue. We cannot simply keep quiet because we have to use the space. But this problem also coming. What to do? If we have to solve the problem, there are two ways. People are talking about two ways. One is policy measures. Okay, what is the policy? For example, COVID has come. What schools or educational institutions, government has taken a policy, government holiday, whatever it is, you got to isolate yourself. Some sort of a policy measures. And another one is a technical measure. You have to get the vaccine, and the vaccine has to be vaccinated to the people with the its time-bound manner and monitor them. So these are all the things, okay? And even if somebody catches the flu or whatever the thing, and isolate them and give the medication for him, save him. Like that we are doing for humans now. Similarly, for the satellites, this issue also, we have the two broader things how to manage this. One is policymakers, that means the governments should understand, because most of the satellites are owned by government. So government should have the thing, the space governance. Space governance means all the satellites, how it be managed, how the frequencies can be given, how one satellite will be launched, how you space the satellites, such that like your traffic control, traffic police is controlling something similar. So one junction is there, not everybody should cross. You put on green signal, yellow signal, and amper. Depending upon that, the people have to take a traffic. I think something similar, not exactly the traffic signal will be there. Something similar, how each one of them face in the space, such that people will not get crowded. That is required. And for that, international cooperation. Whenever somebody launches, I'm launching here, I will put my satellite here, my satellite will work like this. That cooperation should be there. Then norms for responsible behavior. That means whenever you do some satellites, we will keep changing the orbit. When we are doing, we should announce to others such that we will not hit the other satellites. Okay, that is the thing. So for that, you should ready to data sharing of your satellites. Okay, for this, an effective regulation has to work out. People have to follow that. Okay, like standing in a queue, like that. Humans, whatever they're doing, similar way, the satellites has to go in a particular orbit, particular way, particular speed, particular frequency. These are all coming under the space regulation that will be predominantly on the policy measures. But beyond that, technical measures also. For example, debris has come. That means you launch the satellite. After its 10 or 15 years of life, it has become defunct. That satellite is keep on unnecessarily going around, will create a problem, because tomorrow something happens, you cannot move the satellites and it may go and hit, because when it's keep moving around, that same, as I told, 29,000 to 30,000 kilometers per hour speed it's going, it will keep on moving that way only. That's not going to hit somebody. So how to remove the debris from there? One thing. Second thing is, some of the satellites, even about to have some partially funk, is it technically go and correct it? Okay, for example, fuel is over. Before the fuel getting expended, is it to refill the fuel? battery, replace battery, something like that. A faulty system, you're able to replace so that satellite longevity increases. That means, how says a man, if he died, how to avoid him dying. Okay, you would treat him medically such that he, because of his disease, he will not die. Like human we are doing. Similarly, satellites can be done. But eventually, but some whatever it's have to do, if he expires, we have to cremate him. No, you have to bury him or burn him, depending upon your thing. Similarly, the satellites also, the debris removal is either push the satellites towards the ground. When it's keep coming with the fast rate, it will burn itself. So that is one way. Or else you push it away. In Voyages is something called graveyard orbit. From there, it will take thousands of years to come down, so that we are safe. Okay, that similar thing also possible for debris removal. And the space. That is active satellite do, but actually some space debris are coming that you cannot do anything. But for that, you should have an active way of the way catch this debris and bring it. We either push it down or push it up. That's also possible. So another thing is responsible decommissioning. Responsible decommissioning means, you know, the satellite, whatever you launch, every country knows. And this is, we can keep on, like your car, how much fuel is there? Your meter tells now. That means before refueling, next petrol pump comes, another 10 kilometer, 20 kilometer. Whether you have that much fuel, you will be watching. Accordingly, next petrol pump comes, you will charge it. But in the space, technically it's possible, but not many people offer to do it, because either the satellite has become obsolete. There is no point in necessarily doing it. So, but still, its life is about to over. Now you know that 1 kg or 2 kg of propellant is still left with us, but its life will be over another 2 to 3 months from now. But while designing itself, you design such that its life supposed to be 7 years or 10 years. End of the 10 years, you should have additional few kg of fuel. Using that fuel, as I told now, satellite itself can be pushed up or pushed down. Okay, that means responsible decommissioning. One second thing is you switch off the system. I told now 2 interference. One is mechanically can come and hit. Another one is electromagnetic interference also it can go. Though you push the satellite either up or down, so that it no longer it is in the active area of the satellites going around. Then you switch off the satellite so that it will not electromagnetic interference also will not do. So this is called responsible decommissioning. Technically, we should do. Another only traffic management. As I told now, so each satellites keep coming. I'm doing a maneuver, you announce to others, so that they will do something else. Such that how you are managing the traffic in the big cities. Similar thing also, it's possible, technically possible. That's a technical possible. So for that, something called situational awareness. Every country should be aware how their satellites are placed, how the other satellites are placed. So that's why data sharing, other things I told now. So accordingly, people will be able to manage. So these are all the 2 ways of managing this issue. That because we have to make the satellites, you have to launch a satellite. The satellites have to be used. Okay, but you have to manage. Eventually, one-to-one colliding and creating the space as a non-usable place. Further to make, these are all the activities to be taken. So this is globally people are discussing together, and slowly this sort of things is keep emerging. So now this is to when we celebrating Space Week with the space sustainability, to make everyone aware, the next generation of people aware, because next you also should use the space. But for that, you are now itself, you get responsible. You be aware of this. You get educated with this, so that when you take over, you also follow this set of rules. Okay, this sort of norms, this sort of policies. You will not become all of a sudden a surprise for you. You are also part and parcel of this space arena, and the space has to be used by you. And similarly, when you are handing over the space to the next generation, you also should be responsible way you should do it. So for that only, all the scientists are working and emphasizing the policymakers. You also allow us to do it, and trying to educate the students from academia and the researchers, and such that you come out with some research, come out with the thing and be aware of this. I think this is what happening there. That's how we are sitting. Just give us a few examples of can we clean up the space? Okay, thing here. These are all some of the things wherein people are already in an R&D, putting the something into the space, and you define, if you know which is the debris, and the debris can be gone and collected there. Like, I don't know how many of you are aware, in Bangalore, and it's happening there. Some stray dogs, now, if they are going around, then what they will do, they just not bite the people and get into problem. Children will get bitten and they create a lot of injury. So the people will come with something like this, and they'll catch that dogs and they carry. So something similar, go to the space, and this debris, so many small pieces are there. The big, you throw this net, something like this, then you capture it, then come and throw it. Okay, so this is one way of doing this. Some sort of people are doing this way of testing. I think the video is not coming. Okay, this is another thing. Another thing is, in a big satellite itself, it becoming a defect. Okay, but that satellite, we should find it. It's happening. And this is what situational awareness people should share, as my satellite has become defect and somebody wants to do it, please remove this satellite. Okay, like a car somewhere, it got punctured or something like that happen, they will tow it and bring to the carriage, now something like that. Okay, in the space, this also can be done. I think recently one satellite has been launched for this purpose, and of course it has almost done the function, but the test was reasonably good, and probably in the subsequent also Japanese and European space agency doing, and India also planning one small satellite for this sort of thing to be tested. That means it will go and find debris, something like that. It will capture it and remove it. Then after removing, it will come back for the next set of satellites to look for. I think probably I will try to run a video. Let me see that whether I'm able to see that. Yeah. This is a small video of whatever I'm telling. Okay. Hope you are able to see the video now. Yeah, this is on satellite removal point of view. This satellite goes, it's operationalized. Like actually, like the 5-6 satellites they have launched. Their idea is to go and see any non-functional satellite. Now it is going and searching whether any satellite is non-functional. Yes, it is seeing a satellite which is non-functional. This satellite is uncontrolled, but it's keep moving. Okay, it will go and capture that. Now it will do the capturing. Yeah. Then it will do its own maneuver, as I told now, either throw towards the earth or up, depending upon which place it is there, which is easier, which takes less fuel. So now it's thrown out. Okay, now it's coming, it's getting burnt out. Okay, so this is the one of the way. I told now, one is a technical, another one is as I told for the thing. That means space sustainability means be aware of the issue. We cannot close our eyes. Okay, we cannot just keep on launching the satellites. Nothing will happen. It will not help. Okay, keeping in a hope will not help, because this is an issue. So something happens, it's an issue. So it's a global issue today, but it will lead to a personal issue. As I told now, if let us assume your ATM is linked to one satellite, that satellite is hit by another debris. So when you are trying to take the money, you will not able to take the money. Issue is in the space, but the problem is you cannot, when you want, money will not be available. Something like that, many things possible. And as I told now, it can go even connectivity point of view. Instead of, let us assume one super specialty hospital, one specialist doctor, he has to attend to a patient which he is 1,000 kilometers away. Instead of taking this patient there, and you cannot take the patient there, something like that. So when such a connectivity nowadays will enable surgery to be done here with some robotic arms. The super specialty hospital, the doctor sitting elsewhere, he will manipulate the things there. Okay, and this is not only for here, even space astronaut. Something happens we are talking about people going to the moon or Mars. Something happens, to bring back, it will take its own time. but you cannot send the doctor also immediately, and he may not be really flight worthy to go. Okay, everybody cannot go to the space today, but this connectivity helps even there the people to get to be attended medicinal point of view. Like that, many things are possible. So, but some in that whole thing, if some global issue comes like this for the satellite not able to function, that personal issue comes, you will not able to do that function. So we have to sensitize political will for more responsible, because China all of a sudden one satellite is a hit. Okay, to show to the world, I can, for example, Indian space program, so much is coming. Be aware, not only in my army, not only our navy, not only our air force, even space, we will watch you. They want to threaten us, okay? But that sort of things should not be. It's an irresponsible way to show that he spoiled his own satellite, creating thousands and thousands of the debris, and those debris are keep flying around, and that can go and hit the other satellite, create an issue. So people should behave very, very responsibly. So we should sensitize the political will for the also it's required. Politically, people, whether maybe in a scientific organization as well as a government, people should be responsible enough not to do this. I think that's required. Then beyond all these things I showed some of the ways technically we can have the solution to remove the debris. Okay, for that people can be a part of the technical solutions. That's why I told this is basically to make the people aware. Okay, and you be a part of this awareness, and if possible you also come and be a part of the providing a technical solutions. Today we are launching a satellite, people are there. Today we are the people to make the satellites, people are there. Today people are there after launching, how it operate, they are there. And after going around, for example, yesterday you would have seen Chandrayaan 2 discovery of the sodium and the surface areas of the moon. Okay, that map, global map of the sodium map. Sodium map has been given by the Chandrayaan 2. But there is another set of scientists taking the data and doing. But now another group of scientists and engineers are required, such that all our space assets are kept secured way, safe way, such that the whole humanity gets the help of that, so that humanity enjoy the benefit of the space for years to come. That to happen, we need all the things. People be aware, people be responsible, and beyond that, if possible, you can be part and parcel of the technical solutions provide. Good number of new type of scientists, how to safeguard the satellites and how to remove the debris is keep coming now. So this is this particular evening when I'm talking to you, this is to sensitize that, and so that you can be any one of that. Tomorrow you become a leader of the country, you be a responsible, politically responsible, and be an engineer or scientist. Try to see you have another branch of opportunity available, so that across the thing, few thousands and hundred thousands of satellites are keep coming up. Those satellites, how to make it safe, such that space is kept safe. Okay, so this is the for that only. I think this year space and sustainability. When you're talking about space, like a Earth, space also issues are coming. For that, we should be aware of that thing, and we should get ready not to happen this to happen. And for that, I think we should start keeping actions, not only being aware, start taking actions. So this is the idea of this particular meeting, whatever has been I came for you. So now I think it's open for any discussions or interactions. Hope you could follow what I told by and large.
Yeah, thank you. It was very wonderful, and we could listen and we could follow. Our students are so happy. Now we will give the questions. Yeah. So to be very clear, our dean will ask we are already consolidate the questions. We'll put it in a chat box also, so that it's easy for you to read. Then he will read out the questions. We may answer. Okay.
Bye.
Yeah.
So thank you, sir, for your wonderful address on space and sustainability.
Yeah.
Now we have a question from our students. So first question is, how safe is nuclear propulsions, and can we use that for long voyages? Nuclear propulsion. So they are asking about nuclear propulsion technology.
Yeah, it's by and large, the consensus is, as of now, not to use the nuclear propulsion. Actually, not only nuclear propulsion, even any form of nuclear item not to be used. I think that is the part and parcel of that. But beyond that, but there are some areas. For example, when you have to have a rover in the Mars, or beyond that, if it is there, that means the solar system itself, you are going away and away from that. The primary source of sun will be keep diminishing. Okay, its intensity keep diminishing, solar power will keep diminishing. So majority of the solar power is not good enough, and the nights of that planet, the system cannot live. So we have worked, there are the space point of view, worked out, instead of telling totally no, a safe way of, for example, Pluton-223 type of system as a heating sources. Okay, but it be capsured in such a way, even if an explosion comes, it's not create an issue. One way protection, that so many tests that way coming out there, and with that, it's only its own radiation gives a heating, as a heating source it comes, that heat being used for thermoelectric that way. So that way the required electricity is generated, or to keep the system predominantly wherever the solar radiation is there, nights or eclipses point of that time, keep the systems warm, and using some sort of a thermoelectric system point of view to augment the solar power is being done now. But propulsion point of view, I think as of now it is not there, but ion propulsion being used. Okay, this way let us assume the electricity come and ion propulsion being used. That means the source energy source point of view can be some form of a safe nuclear thing. But propulsion point of view and ion propulsion, that means you need electricity to ionize and to accelerate them. So that way, even though when the solar power is not there, an indirect way of nuclear power helping for the propulsion is the now majority of the scientists talk about. So that this nuclear issue, even outer side planets also should not be there, should be safe. So that is the way it's going about.
Okay, so thank you. Another one question. What is your opinion about NASA's recent DART mission, and why can't ISRO try that? Is it really useful or just waste of money? So they have a doubt that is it really useful or just waste of money?
No, I think it's each one has its own priorities. So that way, we don't have that direction the priority today. That's how it's happening. So now you look at here, as far as we are concerned, one is you should be as economical as possible, and you should have a majority of our missions of society relevance. Okay, we would have put one Chandrayaan and now the Chandra 2 missions and the Mars going mission and Aditya will coming. It's only a small fraction of the other missions, and with the having a maturity, and it will have its own, it may not be immediate and some relevance to coming to our organization and the people. So that way only we are seeing priority. So that way, once upon a time we would have told even going to the moon. We would not have told waste, but it was not our priority, we told. If you see, it is not going to the moon is not a fantasy to, we don't have the fantasy to go to the moon. That is how our mission objective started ISRO. But now that is having done many other societal things, then slowly our priority came. Yes, moon also we can do for various reasons. That like that it comes. So these are all the changing priorities point of view in scientific organization of ISRO. Considering ours is predominantly societal thing, and we cannot make an extravagant expenditure. That point of it comes.
Okay, so thank you. And now private companies are into launching satellites, especially in US and all. So is there any regulations to send satellites to orbit? Global regulations?
Yeah, that is emerging. Actually, this is what I when I talk about this policies, when I'm talking about that, I put it that under regulation and the data sharing. I included that. So that point of view, I think even in India, basically every country has been asked. We have a forum called United Nations Forum for the Peaceful Use of Outer Space, UN Corpus, something like that is there in Vienna. So there nearly 100 countries are the part and parcel of that who are already spacefaring and they are entering to space. And now there is some sort of a template being arrived at from that forum, which need to be vetted after properly seeing each country its perspective, such that a global regulation can come. But each country also supposed to have their own space policy. India also, I think the draft policy is already in a place, and it is for the people, academia, and the researchers to give their opinion. And instantly, October 15th to 18th, a 3-day conclave is planned, wherein what Indians, private companies, and Indian researchers, not only Indian researchers, Asia Pacific countries, basically, other, I think, except China and Pakistan, other countries in the Asia Pacific region, including US. US also coming there. So, debating about the various factors about the space policy. Especially, the system is getting more and more privatization. Not only US, in India also, space is getting more and more towards the private companies going to come, including launch and maintaining the satellites going to happen there. So this is getting evolved. Definitely, it's a matter of time. We will have a national policy, which probably will get aligned with the global policy also, and globally also we have a policy that will tell, as I told now, whenever somebody launches, he declares a launching for what, which frequency he uses, and how he is managing the satellite, and all these things. In case of some inadvertent thing, that also is to be told to where and where to be kept, such that a good amount of transparency is happening for the space assets. Whatever assets are kept, that is, everybody knows about that. Towards that, I think the space policies nationally as well as internationally is keep evolving. It's a matter of time. I think it will come through. So,
Okay, sir. One more question, and this question is from my career point of view. A student studying in 7th grade now, and she wants to become an astronaut. And what she have to do to make her dream come true? Is it enough for her to study only school subjects? What she need to learn more?
yeah, astronaut point of view, I think it is a basic graduation will be good enough. The only thing is, it's what is being seen is your physical fitness. It's like that's how the first group set of astronauts from India. Not only in India, it's even the US also happened, Russia also happened. They are all the pilots. Test pilots, not even the normal pilot, they are the test pilots, okay? So that their agility and their physical fitness and how they manage the situation, that point of view being seen there. So by and large, they graduates and that. But subsequently, yes, for example, people like Kalpana Chawla, they have gone, but they are both researchers as well as the research mission specialist. And physical fitness. I think Sunita Williams also it happened like that only. So that's what happened. So it is one is your study minimum, bare minimum is graduation you look for, but then your physical fitness and its own, then it should have its own rigorous training for the space astronaut for the missions we talk about. But beyond that, we look at here beyond that, and nowadays when you're talking about the space tourism, a totally different ball game is coming, wherein you can fly like a passenger. That possibility also coming now. Okay, I know recently a 72-year-old woman, she has gone to the space and returned back. Okay, safely, and she is so happy, and she wants to return back because she was so enthusiastic, so thrilled, so because of the thrill, she could not really that much. She could not enjoy. So once again, she wants to go like that. It's like that means, the travel to the space has very soon is become like you are flying in an aircraft. Okay, but The issue is how to make the aircraft safe, how to make this the space travel safe. That is going to be a real challenge rather than flying in a space. As far as I am concerned, today flying from Chennai to Washington or New York is not difficult. But making an aircraft which can fly 200 people, 300 people, 500 people comfortably to go and come back safely, that is more challenge. So my bet is better to look for, you fly in an aircraft, you fly in a space, but that's not your target. Your target should be how to make the space safe, space travel safe. I think that is more challenge than flying. Wright brothers, that time few people flying test pilots would have been a challenge, but today it is not a big challenge. You have the money, you pay it, and you can fly. So that's going to come very soon in the space travel also.
Thank you, sir. One final question. Poor country like India is investing much on space. Is it justified? Because, for example, in India we have people who are not getting good water facilities, sanitation, and health, etc. So, how this investing on space research will help this common people of India?
Yes, any of you yourself told it's investing. So investing means in return will come a bit late. Okay, it is not extravagance, first and foremost. Second thing is whatever India invests on space is a very, very minuscule of what India spends in the cinema, what India spends in cricket, what India spends even haircutting. You look at okay, how many people every month your haircutting is to do now. Just to calculate and come back, it is a very, very minuscule amount what we are spending. I am not telling we don't do the sanitation other thing, but what I'm telling is beyond that also India is capable of doing very many things. India is having nearly 1.3 billion cell phones. Okay, 1.3 cell phones. Just to count about each person, each cell phone, even 50 rupees per cell phone, if he spends per month, how much money we are going to make. And in that money, 1.3 billion into 50 rupees corresponds to 65 billion. Correct now? So 65 billion, I can make more than 10 Chandrayans. 1 month of what our people cell phone expenditure, assuming it is only 50 rupees charge. So it is, India is not that, nobody, we can stop spending 1 month, people just spiking in a cell phone and make the whole thing clean now. So the priorities are different. So that's why I'm telling. So that people should do that also. But what India spends in the space is a very, very small amount. But that is a big investment. That investment helps India to leapfrog. But because of that only, as I told now, we are able to connect various schools and the ATMs, the reservations, even the border security. I'm telling you today, even to look the borders carefully, the satellites are helping. Today for the rainfall thing, you know, you are near Rameshwaram, Dhanushkodi. It is when Kalam's very young age. One train itself was washed away. Nobody knows how many people died that day. Okay, today we are not hearing about that because today our satellites are able to tell well ahead of time when such cyclone comes. Okay, so these are all the satellites, whatever we invested, that is giving back that much money. Okay, that much return. So thousands of life we are being saved. Today, population density in the regions where we are talking about is much, much more. In Orissa, Gujarat, you look at here, very huge population density in the coastal area. But still, India is a very, very less number of casualties today, thanks to our own satellites forewarning the people such that people are getting evacuated. We are able to save the people like that. Like that, I can enumerate the returns whatever coming to this is much more than what returns India gets team 2020 playing, and what returns Ponniyin Selvan or Vikram or any Bahubali movie is going to give. Much better than that, definitely our satellites are giving much, much better. So it is not a waste. It's an investment for the India's growth.
Okay, sir. So can you give a few suggestions regarding invoking interest on students regarding space science and related space-related field. So, what are your suggestions to invoke the curiosity of our students related to space and space science?
Yeah, this is what basically look at here. What all we are having, the many, very many gadgets in the industries, industry revolution 1 and 2 provided, whether in the motor vehicles or the planes or the regular electricity, electricity driven systems, many things have happened there. Your bulb coming, very many things happened there. These are all the industrial revolutions 1 and 2, then subsequently for the digital revolution. But now when we're talking about the space is being a part and parcel of whatever I told. Now, with that, it's going to happen, many things that happen. And towards that, it opens up various areas of making the satellites and making the launching the satellites and operating the satellite, deriving the benefits of the satellite, and making that the whole thing in being in the safe, such that the whole of the globe and especially our India also can play a meaningful role. So in that first two industrial revolutions, India would not play a major role. But in the digital era, I think reasonably well, our people have done well. And that's why in the big software companies, not only the number of people working Indians are more, even the CEOs and that level, leadership level, India is definitely playing a role. Similarly, not only similarly, even much better way, Indians can do in the world of space. Not only Indian space, world of space you can do. For that, today's youth, I think if they take this is an opportunity, because it's not like when Kalam and all started the space program, very humble beginning, and it's very rudimentary facilities available. Today, India is having the best facilities across the world, either to make a satellite, systems, launch vehicle, launch, and in Kulasegarapatanam, when it's coming, shortly it will happen. The best of the launch station is going to come there. So that way, a great infrastructure facilities will be available. You make use of them. To make use of them, you should have your STEM education to be strong. Your fundamentals to be strong in a STEM. That means mathematics, and your science subject is to be strong, then definitely yourself can connect into the this arena of the space. So that way, it is not flying in a space is a magic. Making your article flying in a space and giving the benefits to the people is going to be a real thing. And for that, you can be part and parcel of this emerging India. For that, things are ready. Only thing is you should get yourself ready and have your education and aptitude clear towards mathematics and science. And definitely you be an engineer, you be a scientist in a space arena, you can do well. You make your name engraved in the future of the India, and which future of India is play a global game in the space arena. And Indian space program is already training every year around 15 countries for the new people to come into the space arena. And those people are going to rely on India to make the satellites and launch vehicle. That is the reason India, beyond ISRO, government is allowing the private industries also to start the work. So that way, it's going like once upon a time, schools only by the government. Now it has gone out. Now our medical centers are only government. Now it is both private and the government. Similarly, even airline was only government, both. Railway is also going to come like that, because it is a competitive world happening like that. Space also going to be like that. So that means opportunities are going to come in a very big way. So that way, to make use of the opportunity, if you get ready with your education, definitely you can be a part and parcel of that activity. Along with the Chandrayaan, Mangalyaan, Aditya missions, we have good number of societal application missions coming in a big way. Numbers are huge, and for that you can be part and parcel of that. Be ready, and your education in a STEM and your understanding of a STEM and your interest in the space definitely will fetch you a good amount of returns, professional satisfaction tomorrow. Monetarily also you will have a good thing, and everything you can do sitting in India itself. Okay, there is no reason to go to other country where your security, other things are all future we don't know. Some question marks are there, but you can do everything sitting in India. space is coming up in a very, very big way. Make use of it. Thank you. Thank you.
Thank you, sir. So we are very grateful for your time. You have spent your time with us today and enlightened us with great knowledge regarding space debris, about the theme of this year's World Space Week, that is space and sustainability. On behalf of Sigaram Academy of Excellence, our director, our team, and our students, we thank you. Thank you so much.
Thank you. Thank you. Thank you.
Okay, students. So now it's on YouTube also. It's live on YouTube. Okay, that's why I'm very serious that you should not sleep and